this blood vessel in the region of the medullary pyramid is the vasa recta, and along with this, there is this loop of Henle. The Henle's loop. In the loop of Henle, the filtrate is moving downwards. In the descending limb, it begins to rise upwards into the ascending limb. Then into the PCT, and it is coming from the PCT. It's coming from PCT and entering into the DCT. Now, this limb, the descending limb, corresponds to this limb in which the blood is flowing in the opposite and upward direction. In the other limb of vasa recta, the blood is flowing downwards. This corresponds to this, and this corresponds to this. The descending limb of loop of Henle corresponds to the ascending limb of vasa recta, and the ascending limb of the loop of Henle corresponds to this descending limb. The ascending limb of loop of Henle passes solutes into the descending limb of the vasa recta via the medullary interstitium. This blood entering into the medullary interstitium begins to take some amount of solutes from the medullary interstitium. ये बीच वाली जो जगह है, यहाँ से solutes किसमें आने शुरू होते हैं? Descending limb में आने शुरू होते हैं. ये कहाँ से निकले थे? Ascending limb of loop of Henle से निकले थे. Ascending limb of loop of Henle से medullary interstitium में, medullary interstitium से some amount of solutes enter into the descending limb of loop of Henle. Right? This is another example of counter flow. काउंटर फ्लो का मतलब होता है ऑपोजिट डायरेक्शन. इसके बीच में काउंटर फ्लो है. इन बिटवीन दीज टू limbs there is counter flow. Also between these two limbs, here also there is counter flow. And when these limbs of two different tubules they correspond to each other, even then there is counter flow. Descending limb with the ascending limb of vasa recta, the ascending limb of the loop of Henle with the descending limb of vasa recta. Again, counter flow. Right? The descending limb of loop of Henle hence passes on water to the ascending limb of the vasa recta. This arrangement helps in conservation of water. This, the removal of the solutes, then removal of the water. Like this arrangement helps in conservation of water. In this way, much of the water is returned back. This water, this blood enters into the general circulation. It goes to the heart via the renal vein. रीनल वेन से हार्ट में चला जाएगा. इस तरह से काफी सारे सल्यूट्स, लेकिन उससे भी ज्यादा वाटर यहाँ से इस एरिया से रिमूव कर दिया जाता है. Now this ascending limb of loop of Henle is actually formed by the efferent arteriole, but not directly. The next page. Let us suppose this is PCT. The arrangement of various parts of nephron are such that this PCT is actually parallel to the DCT. अरेंजमेंट इस तरह का होता है, पीसीटी और डीसीटी एक दूसरे के पैरेलल हो जाते हैं. This is the woman's capsule, this is the PCT, this is the loop of Henle. When we understand this, we draw the diagram of the ascending limb towards the right side. It is not towards the right side. It is actually out of the plane and is here only. It's very close to this. It's very close to this. The ascending limb is out of the plane, and this ascending limb forms the DCT. And the DCT passes between the two blood vessels, the two arterioles, and then it enters into the collecting duct. So, यहाँ पे ये तो बन जाता है वो सिलेंड्रिकल एरिया जिसमें पहले सल्यूट्स भेजे जाते हैं, फिर उसमें से वाटर आ जाता है, और वहां से जब इसमें से वासर एक्टा निकल के जब पास करती है, the vascular recta passes through this area, it takes out water from this area. The PCT and the DCT, they lie parallel to each other, and there is a network of blood vessels around this. This network is known as peritubular network. It's a network of finer capillaries. Peritubular network बोलते हैं इसको, because this is around the tubules. ये इस तरह का एक dense network बन जाता है. This dense network is formed around DCT as well. This network of blood vessels is known as peritubular network. And this peritubular network is actually formed by branching of efferent arteriole. The blood from the efferent arteriole does not return back into the renal vein. दोबारा से अगर वही डायग्राम बनाए तो एक ब्लड वेसल जिसका डायमीटर काफी ज्यादा है, एक ब्लड वेसल जिसका डायमीटर रिलेटिवली कम है, ये ब्लड वेसल ब्रांच कर जाती है। ये हो गया वुमेन्स कैप्सूल। पीसीटी यहाँ है और डीसीटी भी यही है। this one is DCT, this is DCT, this blue one is the PCT. This efferent arteriole immediately branches to form a network around this. इनके चारों ओर यहाँ पे ब्रांचिंग बना देती है। एक ये नेटवर्क बन गया यहाँ पे, और इस नेटवर्क को हम क्या बोलते हैं? पेरिटिबुलर नेटवर्क। So whatever is coming out, whatever contents are coming out from the PCT enter into the blood. जो भी contents, 90% of the solutes, 75% of the water, all of these contents enter the blood. From the filtrate, contents enter the blood. Right? These branches, now the branches of the peritibular network, these capillaries, they unite. All the blood vessels of this area, they unite to form the vasa recta. Vasa recta बनती होती है। पहले blood vessels, efferent arteriole, वुमेन्स कैप्सूल से निकल के यहाँ आई, efferent arteriole ने पेरिटिबुलर नेटवर्क बनाया, और पेरिटिबुलर की ब्लड वेसल सारी की सारी कलेक्ट होकर ये क्या बनाएंगी? दीज वुड फॉर्म, उन्होंने क्या बनाया? वासा रेक्टा। Right? Hence, from this cylindrical area, when this blood vessel, vasa recta, enters into this, in first case, it removes the solutes. It removes the solutes. And then by returning back, it takes up water. This is the vasculature of the nephron. Peritibular network, which is formed by the efferent arteriole. Efferent arteriole. This is the efferent arteriole. The efferent arteriole branches to form the peritibular network around PCT DCT. The peritibular network in turn forms the vasa recta. This is how the blood flows around the tubules and then into the medullary interstitium. And ultimately, it removes solutes and water from this area. इस तरह से यहाँ से ये वाटर को रिमूव करता है। Length of loop of Henle, length of loop of Henle is inversely proportional to the availability of water. Availability of water. If the availability is poor, the length should be greater. If the availability is higher, the length should be reduced. The length should be less, relatively less. Reabsorption via loop of Henle is by counter current mechanism, जो अभी हमने पढ़ा. This is by counter current mechanism. From the ascending limb of loop of Henle, salts enter into descending limb of vasa recta. Then from the descending limb of loop of Henle, the water enters into the ascending limb of vasa recta. This is also known as counter current multiplier. It increases the amount of water, and solutes in the blood. And hence most of the essential substances and water are returned back into the general circulation. इस तरह से वापस जनरल सर्कुलेशन में आ जाते हैं. Now reabsorption in DCT. Reabsorption in DCT. This is the site for facultative water reabsorption. Site of facultative water reabsorption. Facultative means as per the need. This is due to ADH. This is due to ADH. Now, this ADH is known as anti-diuretic hormone. This is anti-diuretic hormone. It is released from posterior pituitary. Posterior pituitary cycle. It is produced in the hypothalamus and causes decrease in the amount of urine formation. If a person has consumed lots of water, then the ADH would decrease. There would be fallen ADH, because then this excess of the water should be removed. If a person has consumed less than required amount of water, then the ADH would increase. तो ADH बढ़ जाएगा. And in this manner, the ADH will help in conservation of water. It also helps in blood pressure regulation. By restoring water lost into the filtrate. ये फिल्ट्रेट से निकाल के वाटर को ब्लड में डालता होता है. Restoring water lost in filtrate. So whenever a person has consumed lots and lots of water, increased amount of water has been consumed, the ADH would decrease. This would lead to increased amount of urine. If a person has consumed less than required amount of water, the ADH would increase. The volume of the urine would, in this case, the volume of urine would increase. The increased amount of ADH would decrease urine output. ये कम कर देगा इसको. It decreases the urine output. So sometimes it increases, it lets the volume of urine increase, and sometimes it decreases the volume of the urine. This is known as facultative water reabsorption. Means depending upon the conditions prevalent. जैसी कंडीशन चल रही होती है उसके हिसाब से वाटर का रीअब्जॉर्प्शन होता है. Next page. Now there is an internal recirculation of urea. This internal recirculation of urea, it is related to the renal pyramid. From the collecting duct, this is the collecting duct. especially the lower regions where it is going to open at the renal papilla. In the lower regions, urea moves out of the collecting duct. Right? This urea, it enters into the loop of Henle. This urea enters into, this goes into DCT, and from the DCT it is again sent back into the collecting duct via collecting tubule. Right? More amount of urea would have entered into this. Some amount of urea comes out of this ascending part, ascending limb from the thick segment. Some amount of urea exits the ascending limb. The thick segment of the ascending limb, right? But some enters into this thin segment and is transported upwards. As a result, this area this zone has higher concentration of urea. Concentration of urea increases over here. This recirculation, this internal recirculation of urea between the DCT and the loop of Henle, this helps in concentrating medullary interstitium further. इस पे अलग से क्वेश्चन आता होता है, तो हमने यहाँ पे डिस्कस कर लिया. Right. Next page. The role of osmoreceptors. The role of osmoreceptors in the body. The osmoreceptors, once stimulated, osmoreceptors stimulated decrease ADH. They decrease ADH. Decreased ADH means increased urine volume. In this manner, you can say osmoreceptors are the receptors which regulate the osmotic potential of the blood. Or simple terms, they regulate water content in the blood. This phenomena is known as osmoregulation. This is mechanism of osmoregulation. This osmoregulation occurs in kidneys. Occurs in kidneys. Both in PCT and DCT, but largely in DCT. ज़्यादा किसमें होता है? DCT में, by facultative water reabsorption. Osmoreceptors would not be stimulated if there is decreased water intake. Like this increased urine volume would occur when consumption of water is in excess. Consumption of water in excess. जरूरत से ज्यादा पानी अगर पी लिया, ये यहाँ से रेगुलेट हो जाता है. Excess of the water would cause the stimulation of the osmoreceptors, decrease in ADH, increase urine volume.